For our project, we chose to talk about the Great Hoover Dam. Because this monumental structure is located in Boulder City, Nevada, we got to take a road trip to explore this amazing engineering marvel that was completed almost 86 years ago. Most dams are built to control flooding, but many also generate hydropower. The Hoover Dam's 17 massive turbines that produce about 4 billion kilowatts per hour a year of hydroelectric power can harness the energy of flowing water to generate an electrical current as they spin. This dam is important to our everyday lives because although the dam lies on the border of Nevada and Arizona, it provides power for California as well. About 15% of the hydroelectric power generated from the dam goes to Los Angeles alone. We will explore some concepts from Chapter 6, Work in Kinetic Energy, and Chapter 7, Potential Energy and Energy Conservation, all from our physics textbook, and talk about the mechanical energy and power of the Hoover Dam, as well as seeing some fluid dynamic properties.
On the upper side of the Hoover Dam lies Lake Mead. Lake Mead is the biggest reservoir in America in terms of how much water it can hold. In this reservoir, water enters the 4 intake towers located on both the right and left side. There are then 4 30-foot diameter pipes, also known as penstocks, that carry water from the intake towers to the generators. Water is forced through narrower penstocks, increasing its velocity and thus its capacity to turn the turbines. Electricity is generated when gravity takes water stored in Lake Mead and turns turbines and generators. This generator has many parts to it that gives it the ability to work the way it does. We will first begin by talking about the base of the generator, where the water enters with a great force.
Before entering the base, the water comes in through the intake towers, which sit at a higher elevation than the generator. Since the water is coming from a higher altitude, gravity plays a huge part in doing the work to bring the water down. This causes the water to accelerate, making the velocity increase before the water enters the base of the generator. Once at the base, high-velocity water enters into the turbine and begins to spin it. The turbine turns a shaft which connects the turbine assembly to the generator assembly. The generator assembly consists of the stator and the rotor. The stator contains copper wire coils that produce electricity when the rotor spins past these coils. This converts potential energy from when the water is sitting in the lake to kinetic energy when the water begins to move with the help of gravitational potential energy. We then get mechanical energy when the water enters the turbines, and finally it all gets converted to electrical energy. This also shows the conservation of energy. No energy has been lost, only converted.
The Hoover Dam produces on average about 4.2 billion kilowatts per hour a year. As we learned in class, power is made up of work over the change in time. We are able to find work by taking a force and multiplying it by its displacement. We can find power in a few different areas in the process of generating electricity. Once the water begins to enter the intake towers, the water comes in with a strong power caused by the gravitational force that applies pressure on the water to enter the long tube. We also see power at work once the circulating water has accelerated and is now moving with a greater velocity than when it first entered. This pressurized water is what helps eventually generate electricity. This electricity then flows out of the dam with the help of transmission towers. The electricity is then able to go all around Nevada, Arizona, and California, providing everyone who lives in those areas with energy to use in their everyday lives. There is a lot more details that go behind the making of electricity, but that's something that we have yet to get into for this physics course.
Thank you guys for taking the time to listen to our explanation of the amazing Hoover Dam. We hope that you learned something interesting about how physics plays a part in dams in the real world.